Hello everyone, welcome to It's All About Economics. And today's topic is measures of central tendencies. This topic is a part of a paper that is called Statistical Methods, and we are dealing with Unit 1A. I'm Suraj Sharma. For more details, you can email or you can text me. So what are the objectives of this particular class? In last class we have gone through about frequency distribution, the graphical representation of the variables using bar charts, pie charts, histogram, and empirical cumulative distribution functions. In this particular class we would be talking about the importance of averages, what is measure of central tendency, and the properties of an ideal measure of central tendency. Moving ahead, a dataset may contain many variables and observations. If the number of variables and observations is large, we may not be interested in each in every observation or the measured value. Rather, we are interested in the summary of the observations, which represents the data in a single value that is meaningful for us. Taking an example from Heman et al. 2016, that a person who wants to go for a trip to some place for particularly the month of December. And he or she wants to get information about the weather, especially the maximum temperature in daytime. Let's suppose he or she collects data on temperature during the whole month are as follows, like 22 degrees Celsius, 24 degrees Celsius, 21 degrees Celsius, and so on. And as this is the month of December, we would be having a total of 31 observations for each day. Now we don't have any idea when the data is shattered around like this, and we want to know some meaningful idea about the temperature, or we can say that we want a summary of these observations. Now, how can we draw conclusions from this data that which particular week or weekend would be better to travel based on individuals' choice on temperature? Now, the observations as a whole is not providing a clear summary for us. So, however, we may compute average temperatures for 31 observations, that is for the whole month of December, and that can be calculated using this particular formula where we get simple average of observations by summing the total observations and dividing it by the total number of observations. As from our earlier observations, we are actually adding up each and every observation, and we get 821, and we are dividing it by total number of observations, that is 31, and we come to a conclusion that the average maximum temperature in daytime in a particular place is 26.5 degrees Celsius. So now we have an idea about the whole observations. For more information, we may see the range or the minimum or maximum temperature during daytime. And for this particular example, this is 21 to 31 degrees Celsius. This is what we have, that particular range. So now we can plan holiday based on these informations. So what we have done is we got an idea about these observations by having a simple average, or the range or the minimum or maximum temperature during daytime. This is how we actually get idea. So coming to measures of central tendencies, that it's a new natural human tendency that people always talk about averages and compare averages for coming to a conclusion. If we take an example that people talk about or judge the efficiency of a vehicle by the average given by that particular vehicle, average kilometer per unit of a particular fuel. And same like we talk about average hours of watching television by people. Now here we see that the term average is used frequently in everyday life to express an amount that is typical for a group of people or things. For example, here we're taking, you may read in a newspaper that on average people watch 3 hours of television per day. We understand from the use of the term average that not everybody watches 3 hours per day television, but that some watch more or some less than that. However, we realize from the use of the term average that the figure of 3 hours per day is a good indicator of the amount of TV watched in journal. So these averages are useful because they summarize a large data set into a single value and indicate that there is some variability around this single value within the original data. So likewise, we can have examples like average marks obtained in a class by a student's most popular TV show or the actor most often selected subject in a course. And for all these comparisons and meaningful interpretations, various statistical concepts of averages are used. It can be a simple arithmetic mean, it can be median, it can be mode, it can be geometric mean, it can be harmonic mean, and so on. But the right choice of average depends on the nature, scale, and type of data or the variable available with us. All these averages are some or the other way describing the location of the data, that is center or the average, and that is why it is called measures of central tendencies. Now, what are actually the averages? Now, according to Professor Bowley, statistical constants which enable us to comprehend in a single effort the significance of the whole are actually the averages. It's an idea about the concentration of the values in the central part of the distributions. It is a representative of the entire distribution. Like we have a class representative in our class who is representing all the students in a class. That is like we have a single value here that is representative of the entire distribution, so we can make idea, or we can come to a conclusion, or we can make inferences about the whole distribution, because we cannot talk about the whole distribution in a single way. Now, requisites for an ideal measure of central tendency, and these are given by Professor Yule. That first, it should be rigidly defined. It means if it is defined, that it should not keep on changing very rapidly. Second one, readily comprehensible and easy to calculate. The third is it should be based on all observations. Mean each and every observation should be used in the computation of that particular measure of central tendency. That measure of central tendency would be ideal. Fourth one, it should be suitable for further mathematical treatment. Means if we have two different samples, we have calculated the averages for both the samples separately, and if we club those samples to make a single sample, then further mathematical treatment can be done using the same idea, or using the same average. The fifth one, least it should be least affected by fluctuations of sampling. We'll be dealing with this. What actually sampling is, it's a method of taking sample. That is what we call sampling. Now the sixth but not the least, the last is, it's not given by Professor Yule, but the important requisites for an ideal measure is it should not be affected much by extreme values. Extreme values are the minimum or the maximum values. If the calculations are based on all observations, the average may or may not be affected by the extreme values. So an ideal measure should not be affected much by extreme values. Like for example, if we have three observations where the values are 150 and 99, and we take the average of 1 plus 50 plus 99, dividing it by 3. Then here the average value would be very affected by the least and the highest value, so this should not be there for a measure of central tendency. So this is all about measures of central tendency. Thank you so much for being with me. In next class we will be particularly talking about the arithmetic mean. Thank you so much for your time.